Alright, Mr. Spainhour, this is initial test I'm showing you. I've been through quite a bit, so this is what I've got so far. This is Microsoft Paint. I've just got a black background. The video recorder I'm using is Cam Studio. As you look through it, you'll see here. The video size gets pretty big pretty quick. As long as I stay below 2 gigs on this, I'm fine. So as you can see, I've got quite a bit of recording time. I'm sure there are ways around this if we decrease the video quality. The rest of this other stuff's not important. But I found out I have to keep this below 2 gigs. But in the background, I have the black. I've tried using green. It looks pretty good. As long as you can see this, it's awesome. This is just squiggles or someone's signature, whichever way you want to look at it. Um, I'll undo that. Just a quick sample problem. We can see the possible problems. If I want to say have a guy jump off a building, and just so it's easy numbers, I'll say the height of the building is 100 meters high. You can see it stinks, and whatever's on the top, I don't know, it looks like a banana or a, I don't know, an ice cream cone without much detail. Maybe let's make it a double scoop. There we go, it's a double scoop and a horrible cone. Anyway, this thing falls off. We want to find out how much time it takes to hit the bottom. So we might come over here with our givens. I guess we need a ground. Say, oh, I know the displacement, and I know the acceleration, which I'll call acceleration is g. Letters are horrible to draw on this. It takes forever. The displacement is, I guess we should set up a sign thing. We say up is positive, down's negative, so this would be actually negative g, and our displacement would be negative 100. Oh, this is on the mouse, by the way. This isn't on the tablet. I haven't got that to work yet. But there's no way of doing this with a mouse long scale. We know the initial velocity is just sitting there, assuming. I'm not trying to turn this into a projectile motion problem. Just assume he's falling straight down. Straight lines are also hard to draw. Like if I want to draw a rectangle, I've got a little practice, I'm okay at that. Triangles sometimes look like triangles, they don't, that's not bad. And the master level stuff is the circle. At least you know I meant to draw a circle. So I guess this is what we start out with. What are we trying to find? We're trying to find not the displacement, the time it takes to hit the ground. Okay, so we come down here, we write down an equation. Here's the painful part. Displacement. Now remember, this is with a lot of practice, so this is as quick as it's going to get. The initial velocity times the time period. That's a delta, believe it or not, a t, plus the acceleration. What do we got? Delta t squared, and all this is over 2. Normally I put the 1/2 out front like here, but I forgot. We see the initial velocity is 0, which would go right there. So that makes this whole thing 0. So we can just kind of get rid of it. Delta x equals, excuse me while I sigh, because writing out these letters is tedious. Okay, still want to solve for the time here, so we gotta get rid of all that stuff. Multiply both sides by 2. Hello, Max. He's pulling on my microphone. He thinks this is hilarious. We also have to divide both sides by a. And then to take the square root. I would, for the children, I suppose, rewrite this out every time, but you can't believe how tedious this is with the mouse. Hi, Max. Yes, I know you want to remove the microphone from my head. Thank you. Oh no, I'm out of room. Dun 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 dun. That's right. It scrolls. It's magical. I don't care if you guys like it or not. I found it impressive. Anyway, we got all this stuff over here. The square root of 2 delta x. You see the delta there? Good. Over a equals, all that's left now is just this delta t. Max, I love you, buddy, but please. Daddy's working. Alright. Why'd I write that in there again? That's gone. Alright, so we got this all is equal to the square root of 2 times delta x. If we come up here, the delta x was negative 100. Negative 100. 100 meters. I'm falling for so far. I guess that's what an ice cream cone would sing when it's falling. The acceleration come up top is negative g, which we know to be negative 9.1 meters per second squared. Anyone want to take a guess how many times I've done this and had the recording come back and say, I don't want to record it? If you answered a lot, you are correct. 200 over negative something or other, 9.81 meters per second squared, square root. That's about 10. I could do it rough calculations in my head. I'm sure there's better ways to do it. I have the calculator up here. Negative 200. What do we got? Does this even do negatives? Yes, it does. We got negative 200. I said negative. Actually, it doesn't care. It's not a voice recognition software. Divided by 9.81, also negative. That equals 20. I in the future write some numbers over here with a bunch of other numbers. And come up to the calculator. I also have to take the square root of this. Square root. So that's our answer. Far distance he only falls for 4.51 seconds. 4.51 seconds. Okay, or I guess if you were rounding, it'd be 5.2. But good things about this, bad things about this. Here's where we are now. So, anyway, if you take a look at this today, awesome. If not, I'll see you tomorrow.